All right, guys, in this video, we're going to be looking at some of the separation techniques to separate solutions, and we're looking at two multiple choice questions. So, which of the following questions about the components in a mixture could be investigated with a paper chromatography experiment? Now, without even looking at the answer choices, paper chromatography, the purpose of it is to distinguish between two different polarities of a substance. It could be a dye, it could be other things. And we're trying to find the answer choice then that's going to talk about polarities or differences in intermolecular forces. So do the components have different densities? Nope, we're not looking for, and paper chromatography will not help us with densities. Molecular masses, also not what we're looking for. And here is molecular polarities, so there is the right answer choice. And then average molecular speeds, that's not going to help us. Once again, paper chromatography, the whole purpose of it is to distinguish polarities between two different molecules. Okay, and here's one more question. We got two different molecules shown. The Lewis structures are above, ethyl acetate and butyl acetate. A mixture containing equal numbers of moles of ethyl acetate and butyl acetate was separated using distillation. Based on the diagrams above, which of the following identifies the substance that would be initially present in higher concentration in the distillate, and correctly explain why that occurs? Okay, first off, distillation. So you've got our solution. We've got butyl and ethyl in here. And we're trying to separate it with distillation, which means we are going to add heat and cause it to boil, and something's going to come out first. That is what we call the distillate. So we're looking for something with a lower boiling point. Whatever has a lower boiling point is going to boil first. So that's what will have a higher concentration. Now, boiling point is based on intermolecular forces. The weaker your intermolecular force, the lower your boiling point, and the stronger your intermolecular force, the stronger the boiling point. So looking at these two, and we haven't even looked at the answer choices yet, between ethyl acetate and butyl acetate, we can try to identify what kind of intermolecular forces they'll have. Now, they're very similar. If you notice, Lewis structure-wise, they're very similar to each other. We have this little part right here that's exactly the same. The only difference is this butyl acetate has two extra carbon chains compared to the ethyl acetate. Now, in terms of intermolecular forces, it looks like both of them are polar, so they should do dipole-dipole forces, and they should be about the same strength in terms of polarity because of this section right here. But because of this extra chain, the dispersion forces on ethyl acetate should be stronger than ethyl acetate. Remember, dispersion forces increase in strength as the molecule gets bigger. We're adding more electrons, so the electron or the molecule becomes more polarizable is the word that we'll use. So looking between these two, my guess is because butyl acetate has stronger intermolecular forces, ethyl acetate is going to be a higher concentration of distillate. It's going to have the weaker intermolecular forces, so it's going to boil off faster. So looking at these answer choices, we know C and D aren't right because it's assuming that butyl acetate is going to boil off first, but we know it's ethyl acetate. Right here, this one's not right, A, because it's talking about breaking bonds, and boiling is not breaking bonds, it's breaking intermolecular forces. They're going to put this in the test to try to throw you off, okay? And B is the right answer because, yes, it's talking about how it has a shorter chain and weaker London dispersion forces compared to the butyl acetate. So definitely B is the right answer here.